Okay, so I think I've already written all this down. We want to see how this applies to this curve. Inside, the right-hand rule tells you that the current created by, the magnetic field created by the current in any loop is along the axis. So all these currents reinforce. Meaning that your magnetic field inside of here is always in this direction. Okay? And I think in the last one, yeah, okay, I used yellow for the magnetic field, right? So you just take, and it should be uniform as long as you aren't too close to the edges, to the ends of the solenoid. Okay? Just a symmetry argument there. And another argument tells you that the magnetic field is pretty much zero out here. Because if you consider the field due to this loop or coil, whatever, at this point, and the one from here, they're equal and opposite. They just cancel out. Okay? And that's not what happens inside. And your book can give you a really good explanation of that. If I lay any more than that on you, you're not going to understand it, which is why you go read the book. And it won't take you long. Okay? Just look up Ampere's law and look up the field of solenoid. You'll get it. Okay, well, the result is then fairly simple. Now I'm going to ignore this and this. Okay? Because again, symmetry argument tells you whatever the magnetic field does along here is equal and opposite to what it does here. The magnetic fields are equal, but you're going in opposite directions. I'd said that wrong. No, the magnetic field, anyhow. Okay? Actually, magnetic fields here are just zero. So it doesn't matter. Okay. And again, read the details. So that the integral just b times L. Whatever segment, it's b times the length of that segment. B is the same for every segment. So when you add them up, it's just b times the sum of the lengths of the segment, which is the length of this path. Okay? So there you have it. So that b times L is directly proportional to I times N times L. Okay? To get the proportionality constant, you just have to consider the field of a small loop at its center. Okay? And then what's the line integral of a loop that does this? So I'm going to leave it at this. This is how you calculate the field of a solenoid. It's not I that we're solving for, it's B. B equals and I'd said equals, it's proportional, it's a proportionality constant. But it's just your current times the number of loops per unit length, number of turns per unit length, okay? And the proportionality constant is just some multiple of k prime. Maybe it's 4 pi k prime. You find out and see if you can understand why, okay? I'm not going to tell you without deriving it. We just don't have time for me to derive it. It wouldn't take long, but we got other things to do. It's straightforward.